Team members signing Section C on job planning document for hazards. For those individuals working on any job requiring a job plan at Central Maintenance Services, Part C, Steps, Hazards, Barriers, and Record of Changes must be filled out and signed. Columns where information is entered include Date, enter date. Job step, work operation, or changes. List the job steps, work operation, or changes, followed by related hazards or barriers. By, enter initials of worker assigned to this step. Hazards. List any and all hazards for each step, work operation, change, or indicate reference to appropriate section on checklist. Barriers. Use and attach the appropriate checklist or checklists from the appendix for each hazard and/or describe in detail a specific approach to eliminate and/or control the hazards. Checking the vacuum gauge in the morning after the all-night vacuum draw. After pulling a vacuum on the refurbished bushing overnight, check the vacuum gauge to determine the reading in the display window. If the gauge indicates that the vacuum level is the same as it was initially, then the vacuum test has been successful. The result is a confirmation that all the O-rings and gaskets are firmly in place and that there is no space between the individual parts that is not effectively sealed. Begin removing the belts and slings that were used to move the bushing into the service well.
Yeah, I'm going to drop it down with the crane. We're going to hook up the oil line to it.
Remove the vacuum hose from the quick connect on the top of the oil reservoir tank and let it stay resting in the sling so that the crane operator can retrieve it from the hoist hook.
Okay, I'm going to take it south.
One step forward, good.
Yeah, there you go. It's stepping above that, right? That matters.
The crane operator can remove the vacuum hose from the hook and store it for future use.
That's good. We're done with that. Okay, so. All right.
Refilling the bushing with oil and drawing a retained sample of oil for analysis and reference.
Okay.
Rest 3 or 4 feet of the hose that will be used to deliver oil to the bushing into the same sling that the vacuum was returned in.
I'm part of the team. I'll be in there.
Okay. Here, just spin it here, Graham. Just.
Wrap one end of
All
the
right.
sling around the hose a few times to secure it, and
Just
then
makes it a little
reattach
tighter.
the sling to the hoist hook.
Okay, Sam.
Deliver the hose, by using the crane, to the team member on the ladder beside the top of the bushing.
I'll go turn on the main valve over there. Yeah, he probably does.
Oil to refill the bushing is stored in a blue oil storage tank that holds approximately 6,000 liters of oil. Open the main oil valve located at the bottom of the west end of the tank. By opening this valve, oil will flow to the pump, which will then pump it through the hose to the point of use.
Okay, it's open.
At the main control panel, turn on the main power by pulling on the red emergency stop button.
Now I'm going to turn on the control power.
Turn on the control power.
Wait 1 second.
Okay. Now the power just came on. Did you notice those lights?
No, we'll do it again in wider shots.
Followed by the vacuum pump.
Then I'm going to hit the vacuum pump start.
Then switch the vacuum
Then
booster
I'm going to
to
hit the
auto.
vacuum booster.
And then switch the inlet pump to auto. Finally, turn the switch below the red emergency stop button to auto.
That's it.
That's it. Now everything's on, ready to pump oil.
We'll just get a wide shot here of the unit.
After all the switches are turned on, degasified oil can begin to flow through the oil hose for delivery when the valve at the end of the hose connected to the bushing is opened. Other lights on the panel indicate which of the other elements in the degasification process are engaged. Connect the oil hose to the inlet on the top of the oil reservoir tank. The flow of oil through the line is 13 liters per minute, as indicated by the inline flow meter. The indicator needle for the level gauge will start to move up when the oil begins to enter the reservoir tank. The scale in the display window is a temperature scale due to the fact that the volume of oil increases as the temperature increases. Since the CMS working environment is maintained at about 20 degrees Celsius, the
coming up.
bushing will be filled to that level.
It's coming up. No, just keep her going.
When the oil reaches the top of the bushing during the filling process, the indicator needle in the display will begin to move up.
Take it just a fraction above 20, right?
When the oil level reaches 20 degrees Celsius, then turn off the pump to stop the filling process.
That's
A
it.
team member standing on the ladder can control the flow of oil into the bushing by controlling a manual ball valve installed below the quick connect coupling on the end of the hose delivering the oil.
Okay, I'm just going to reverse the procedure I just went through. I'm going to start shutting things down.
To shut down the oil flow to the bushing, simply reverse the procedure used to initiate the flow.
And then shut off the main power.
The valve at the base of the oil tank must also be closed.
Done.
Disconnect the oil hose from the connector mounted on the top of the oil reservoir tank. Wipe the end of the hose with a sheet of oil-absorbent material to prevent oil dripping onto the floor as it travels back in the sling. Disconnect the connector couplings mounted on the oil reservoir tank and wipe them clean of any oil.
Now, this would be a good time to take your oil sample.
When the last connector is removed, there will be a hissing sound heard from inside the reservoir tank as the vacuum pressure inside the tank equilibrates with atmospheric pressure
have to.
outside the tank.
Oh yeah, the vacuum, oh yeah. Yeah, excellent vacuum, eh?
When the oil hose is returned on the sling, remove it and coil it so that it can be neatly stored on the side of the degasifier.
Okay. There you go.
Using a plastic sample bottle equipped with a length of clear plastic tubing, withdraw a sample of the oil from the port used to fill the tank. Depress the bottom of the plastic bottle while simultaneously immersing the end of the plastic tubing into the oil. By letting the bottle expand, the oil will be pulled through the tubing and into the bottle. Transfer the oil to a clear glass vial that has been wrapped with tape so that it can be labeled. Fill the vial to the top before screwing the top on.
Ta-da.
From the identification plate that was attached to the bushing, determine what the serial number is.
Okay.
Using a permanent marker, write the serial number of the bushing on the tape
That's gonna
wrapped
be
around the vial
3BB.
that will be sent for analysis. Close-ups of original bushing tag with data. Every bushing that is manufactured has an identification tag attached to it on the outside of the unit. Due to the fact that weather conditions vary, along with the length of time the bushing may be in service, the bushing manufacturer embosses the information on the tag so that it is permanent. If additional information about a specific bushing is required years after it was put into service, the identification tag makes it possible to trace the specifications that are on file with the manufacturer. The information on the tag includes the name of the manufacturer, the serial number, the rated voltage and amperage, the length of the unit below the flange, and the date of manufacture. For the bushing in this library module, the manufacturer has included the artwork number and capacitance measurements on the tag as well. Lifting the bushing from the service well so that the flange can be painted. In order to lift the bushing out of the service well, slings are attached to two eye bolts that are installed into the surface of the flange on opposite sides. In order to optimize weight distribution during the lifting process, both slings should be as close to the center of the unit as possible. This will help to ensure a straight and balanced lift. If one sling is further away from the center of gravity than the other sling during the lift, then the unit will tilt and become unbalanced. When looking up the bushing, it's apparent that each sling on the side of the bushing is a different distance from the center of the porcelain, and for a balanced lift, they should almost be the same. To bring both slings as close to the center of the bushing as possible, the crane operator must first adjust the tension on the slings to remove any slack. Working from the mobile ladder, a team member should secure the two slings on either side of the bushing to the oil reservoir tank. Use two belts placed above and below the level gauge on the tank and firmly tighten them using security buckles that do not rest on the display window. The crane operator can now be reassured that the lift will be as balanced as possible when raising the bushing up. Sealing the oil fill port on the oil reservoir tank with the gasket and plug. During the refurbishment process, the port on the top of the oil reservoir tank has been used to drain the oil, to draw a vacuum, and also to fill the bushing with oil. It is now time to close the port by plugging it. Begin by inserting a new cork gasket of the appropriate size and manually pushing it to the bottom rim around the base of the threads. Screw the plug into the hole and manually tighten it, and then using a wrench, tighten until it is firmly in place. To replace the flange on top of the conductor core above the oil reservoir tank, it will be necessary to have a chain wrench, a jar of white petrolatum, the new O-ring, and the flange. The O-ring will be installed attached to the flange so that when it's in place after the flange has been screwed in, it will be seated around the inside rim of the conductor core. When reinstalling the flange, place the O-ring over the threads of the flange, and then move it down over the threads so that it lies against the bottom of the flange. Cover the O-ring liberally with white petrolatum all the way around the ring. Begin by screwing in the flange manually until it's tight. Use the chain wrench to firmly tighten the flange to the conductor core. To reinstall the terminal at the top of the bushing, seat the new gasket around the outer rim of the underside of the terminal while it's on its side and resting on the top of the reservoir tank. Seat the terminal into position on top of the tank and align the holes on the surface of the terminal with those in the tank. Begin inserting the bolts into the holes on the surface of the terminal. Use a ratchet wrench to tighten all the bolts firmly. Inspect the installation to ensure that all the bolts have been installed all the way around the terminal, and that all items have been removed from the top of the bushing. Preparing the new MDOF brass tag to reflect the new service information. The MDOF number is entered in a logbook that is updated with the information pertaining to the work that is performed on a specific bushing. After the completion of the refurbishing process, the MDOF number assigned to the bushing must be embossed onto a brass plate that is mounted onto the body of the bushing. To emboss the brass plate, lay a strip of tape across the top and bottom portions of a brass tag so that it is firmly attached to a very hard metal surface. Obtain the MDOF number from the logbook where the entry was made. Obtain a set of hand punches containing the letters and numbers required to emboss the tag. Using the appropriate punches, punch the MDOF number into the brass section of the tag between the two strips of tape reading from left to right. Use the bottom edge of the tape as a guide when laying the head of the punch on the tag. When embossing a letter or number on the tag, simply make one stroke on the punch. Emboss the letters MDOF to the right of the left hole in the tag. 57.6. Emboss the numbers starting from the left edge of the right hole. This means that the last number should be embossed first. This will ensure that there will be enough space on the tag, because the amount of space between the first number and the last letter will not matter. Raising the bushing from the service well. Clean, prep, and paint flange. Seal the flange with silicone and let dry overnight. Begin applying tension to the slings that are attached to the flange by raising the hoist hook very slowly at first. Watch the movement of the flange as the bushing is lifted very slightly off the floor in very small increments. This will allow the crane operator to evaluate how balanced the lift will be.
Doesn't look too bad. Taking it up.
If one of the slings is lifting more weight than the other, the bushing may have to be moved a bit more in one direction to ensure that the bottom porcelain will not clip the edge of the floor on the way up. When the necessary adjustments have been made, lift the unit up to about chest height.
What do you think? Pretty good level right there? Okay.
Spray all around the ground sleeve with isopropyl alcohol. Begin wiping down the ground sleeve to remove excess oil and debris. Use a pneumatic electric drill equipped with a wire brush attachment to remove any of the stubborn spots of accumulated grime. Spray all around the surface of the flange with isopropyl alcohol, and using a paintbrush, spread the aerosol droplets from the spray over the entire surface. Spray and scrub the upper surface of the rim around the lower part of the ground sleeve, where the accumulation of debris is heaviest. Since the surface is flat, it is very easy for this area to have a buildup of oil that can remain there and harden. Spray the surface on the underside of the flange and wipe it as clean as possible. When the upper portion of the flange has been cleaned, begin painting it using standard gray-colored paint. The upper portion includes everything except the underside of the flange. When painting, a half-face air-purifying respirator with the appropriate gas vapor cartridges as well as safety glasses must be worn. Paint around the capacitance tap right up to the edge of the opening. Screw the cover back on the capacitance tap so that it can be painted also. The cover will be removed later during testing, but should be painted now. When it comes time to paint the underside of the flange and the ground sleeve, the dielectric paint Glyptol must be used. Glyptol is a non-conductive paint that acts as an insulator. Take a moment to read the instructions on the label. Obtain a caulking cartridge of seal-proof SCS 2000. This is a silicone sealant for use in most weatherproofing applications. After application, the sealant reacts with atmospheric moisture to produce a long-life silicone rubber joint and glazing sealant. Apply the SCS 2000 sealant around the base of the upper porcelain where it meets the flange. The flange is wider than the porcelain, and so there's a gap that can be filled with the sealant. Apply the sealant all around the base of the porcelain liberally to fill the gap. Apply a wide strip of masking tape around the top rim of the lower porcelain. This will prevent any paint from accidentally landing on the porcelain when painting the ground sleeve. Begin applying Gliptol paint to the ground sleeve from the edge of the lower rim up to and including the underside of the flange. The areas painted with Gliptol will be in direct contact with the transformer when the bushing is installed. The dielectric properties of the paint will improve the bushing's ability to function as an insulator. Wear appropriate gloves when applying the sealant. The application of the sealant can be happening at the same time the ground sleeve is being painted. When finished applying the sealant all the way around the base of the porcelain, smooth out the seal by running your gloved finger over the top of the sealant. Allow the paint and sealant to dry for an appropriate amount of time.